We are back with skills from first year chemistry. This is part 2 of 3 on 105. This is our first combustion analysis example. And I'll just read the example while you write it down in your notes. We have 1.50 grams of a hydrocarbon, which you guys know is CXHY, undergoes complete combustion to produce 4.40 grams of carbon dioxide and 2.70 grams of water. And the question is, what is the empirical formula? So we want to keep in mind that all of this carbon in the carbon dioxide came from this carbon here, and all of the hydrogen in the water came from this hydrogen here. So we're going to do a little bit of stoichiometry to find the number of moles of each carbon and hydrogen, and then we'll divide both moles by the smallest moles, and our quotients will be our subscripts there. So, of course, we are going to start off with our 4.40 grams of carbon dioxide and our 2.70 grams of water. And our first job is to, of course, convert to moles. So we know the molar mass of CO2 is 44.009. And then we know the ratio that 1 CO2 mole means 1 mole of carbon. And that will get us to moles of carbon. So we're first going to go 4.40 divided by 44.009. And that gives us moles of 0.099795. So that's moles of carbon. And I didn't pay attention to significant figures there because that's not my final answer. And then with water, same thing. We're going to convert to moles. And we know that the molar mass of water is 18.015. And then our mole ratio is just a little bit different here. We know 1 mole of water gives us 2 moles of hydrogen. So it's really important that you have that mole ratio there. So we're going to go 2.70 divided by 18.015 times 2. And that gives us 0.29975. And that's moles of hydrogen. So let's take a minute to analyze who's smaller, 0.0999795 or 0.29975. And of course, we're going to choose the moles of carbon as our smaller number. And so we're going to divide both moles by the smallest moles. So we'll divide by 0.0999795. So this quotient is going to come out to be 1. Hopefully you guys can see that. And then this quotient, if we do it, 0.29975 divided by 0.0999795, and that gives us 3, or 2.99 so that tells us that our empirical formula comes out to be CH3.
I'm going to the bathroom.
Okay. And that brings us to the end of this problem. So we found our empirical formula to be CH3. And before you end the video, I just want to point out that this number at the beginning, the 1.50 grams of a hydrocarbon, was a piece of distractor information. You didn't have to use that part of the problem. So just be mindful of that. Thank you.